Hello students, in this session we will be discussing about the wears on the rails and the defects that occur in the rail section. Shown you here. So to begin with that, first we will be discussing on the rail wear and then we will move on to the defects in rail. So first we will understand what is a rail wear and what are the causes for the rail wear. So you can see here in the picture, so on the head portion, so rail wear occurs especially on the head portion of the rail section. Since the head portion is the one which is in direct contact with the wheel, because of the application of this heavy loaded wheel on a small concentrated area, so there are chances that there will be a metal loss on the surface which is in contact with the wheel. Okay, so that metal, the loss of metal because of the friction, continuous friction between the steel wheel and the steel head, so that we call it as the rail wear. So as you can see here, the rail wear can occur either on the vertical wear, so vertical wear that will occur on the top of the rail section, and the rail can also be the lateral wear. So lateral wear is nothing but the wear which occurs on the sides portion of your rail section, that we'll call it as the lateral wear. Apart from the lateral wear and the side wear, we have one more wear that can occur at the end. So here the rails runs in some direction. So the rail section will have the particular length. So at the end of each and every rail section, there are chances that the wear will occur. So this we will call it as the end wear. We'll look into the what are the various causes which will contribute to the occurrence of the rail wear. So the first cause is due to the passage of a moving load. The friction between there exists a friction between the rail and the wheel section. So because of this friction which is there between the steel wheel and the steel rail, so there will be a loss of metal on the top surface. That is the first reason. The second reason that can also be due to the impact of moving load. So the effect of forces of acceleration, deceleration, braking of wheels and abrasion, so due to the rail and wheel interactions, that can also be the cause for the rail wear. And apart from these two, so there are weathering condition, that is the change in temperature, snow and the rain, and also the presence of some of the materials like sand that will also contribute to the rail wear. And some of the cases, especially when it comes to the curve, so we can expect this lateral wear. So lateral wear will come to picture only at the curve section, not on the straight section. So that occurs because the more lateral force is exerted on the outer rail because of the centrifugal force that have been developed. Okay, so here the lot of metal of the rail get worn out, that will cause the whenever there is a worn out section, that will cause the loss of metal in the rail section due to the several reasons that we have mentioned. So now because of the loss of metal, you should, whenever there is a metal loss, that should be ensured that the whatever the stresses that exceeds, that will be within the permissible values. So if at all, if you feel like, if I find that the stresses are exceeding the permissible values, so the rail section need to be renewal, or it can be completely replaced. Okay, here the picture here shows you this is a typical rail section without any wear, and you can see here there is a sides of the rail section is got, both the top as well as the side of the rail section has been completely worn out. So this can be the causes or picture. So you can see here, so this was the original rail section. So you can see here both the top side there is a wear, you can see, as well as both on the sides. Okay, so if the wear occur on the top or here. So now here next we'll move on to the orally classification of the wears, how you can classify it. So the first classification is based upon the location where the wear is occurring. So now we can see that the wear is predominant in some of the location like on sharp curves. So frequently the wear occur on the sharp curves and on the gradients, and also approaches to the railway stations where the brakes are frequently applied, and in the tunnels, and also in the coastal area due to the action of breeze, the corrosion of the metal takes place and that leads to the wear. And also, whenever the track is taken on the weak foundation, sinking of rails can occur due to the heavy loads, which gives the uneven surface, which will result in the wear. Okay, so these are the some of the places where the rail wear is predominant. The second classification, which is of more importance, is the based upon the position of the rail wear. So we have already saw that in the first slide. Okay, what were all the various positions that can occur on the top or on the sides or at the end of the rail section. So now, depending upon the position where the wear is occurring, so we can classify into the three types. So first type is the on the top of the rail head, so that we call it as the vertical wear. So vertical wear, this will occur both on the tangent track. Tangent track is nothing but the straight track. So this can occur both on the tangent track as well as on the curves. The second position where your rail wear can expected is on the rail sides of the rail head. That is nothing but the lateral wear. So if it is a rail section, if the wear occur on these sides, so top, it will call that as the vertical wear. If the wear occur at these sides, we call this as the lateral wear. So your rail run longitudinally, and if that occur at the end portion, that we call it as the rail wear on the ends of the rail. So that can also be called as the battering of the rail end. So we will discuss in detail what are the reasons for the occurrence of the various type of rail wear on the different position, and how it can be rectified. That will be discussed further. The first type of the wear, what you can see, is the wear on the top of the rail. So that will occur on the top end of your rail section. Okay, so that we wear on the top of the rail. So that can also be called as the vertical wear. So this vertical wear can occur on both on the tangent track as well as on the curve. So tangent track is nothing but the straight track. So straight track can also be called as the tangent track. Okay, so now here what are the reasons which is causing the wear on the rail section of the tangent tracks and the curve section, that will be discussed. The first one reason is due to the flow of metal. So why the metal will flow? So because here heavy wheel load is acting on a very small concentrated area. So you know that all the rails will carry a very high heavy loads. Okay, so that load, all the loads will be transferred to the small area, means the you might have seen the wheels. Okay, so wheels, the contact area between the wheel and the rail section is very small. Okay? Because of this small area, which will produce the largest stresses, and when the stresses exceed the elastic limit of the material, so we can see the flow of metal. So it will have the metal start flowing in the direction of the movement of the rail section, and that will create the formation of burrs will be formed. So that is the one reason for the occurrence of the wear. And also because of the axle load, the impact of the reoccurring impact of the heavy axle load, that can also causes the wear on the top of the rail. And also wherever there is a frequent application of the brake, especially on the gradient, so there are chances that the rail wear occurs on the top. And also the abrasion of the rolling wheels, and because of the abrasion, generally the rail top of your rail get generally worn out. And sometimes in the tunnels, so we will use tunnels, the sand will be used spread on the rail section to produce a friction in case of the dampness. If the tunnels are in very damp, to impart the friction between the rail and the wheel section, the sand will be used. So the presence of the sand, that may cause the it will cause the grinding action of the sand particles. Ultimately the rail gives rise to the wear. And also due to the change in the gradients, that can lead to the frequent applications of the brake, so that may leads to the rail wear. And the last reason is the corrosion of the rail by the action of the sea brakes, so that may also give rise to the wear on the top of the rail. So these are some of the reasons why the wear occurs on the tangent tracks. But when it comes to the curves, what is the reasons which is making your railway it is quite different compared to the tangent track. So here on the curve, there is due to the slipping and skidding of the wheel occurs, and which may leads to the wear. And also there is a effect of the centrifugal force. If the improper super elevation is provided, the load on the one rail is greater than the other rail, so resulting in the more wear due to the heavy concentration of the stresses. So these are the reasons. Picture here will shows you the how the rail bend occurs on the side wear. So you can see here, so both the sections should be symmetrical without any wear, but you can see on the sides, so completely there is a metal loss here on the side. So this is how the rail wear, call it as the next picture. So here metal will flow and the metal will be accumulated on the one places. So that accumulation of the metal at one particular concentrated place, we will call it as the burr. Okay, so this whatever the burr it will form, that get later chipped off because of the moving wheel flange. So why the rail wear is occurring? So this picture here will shows you the how where rail wear occur. The first picture here, this picture will show the vertical wear on the tangent tracks on the straight stretch, how the rail wear occur, and other two diagrams, so that will gives you the on the curves how the rail gets wear. So on the railway track, so we'll have the two rails. One is the on the curve, so whatever you have it at the inner side, so this will be the inner rail wear, and whatever the rail wear occurs on the outer side of your rail, that we call it the outer rail wear. Okay, so now here the inner side you can only see the rail gets wear on the only on the top, but on the one which is on the outer rail, so there is a more concentration of load because of the centrifugal force that has been developed. So as a result of it, so wear occur on the outer line, wear occur both on the top side as well as on the sides, as you can see here in the picture. So outer rail is subjected to the both the vertical wear as well as the lateral wear, whereas your inner rail is subjected to the only the vertical wear or the wear on the top of your rail. So now here look into, so how to what is the next type of the rail wear? The next wear is the rail on the ends of the rail. So you can see here there's a first rail section, and that ends at here somewhere at this point, and from here the second rail section start. So now whenever you connect the two rails with the help of the fish plate and fish pole, a sufficient joint will be provided for the expansion. So now when the this wear on the rail end occurs due to the combined action of the both static pressure as well as the impact blows. So whenever the rail moves from the one section to the other section, there will be a sudden jump over this gap, so which will give rise to the blow to the end of the rail. So because of the frequent application of such static pressure as well as the impact load, what will happen? The ends here that get battened. So you can see here the ends get battened here. So as a result of it, when the ends get battered, that will results in the rough riding track, and also the whatever the ballast packing we have below it, that also get loosens, and that even disturbs the railway sleepers of the wear. So now we'll look into the what are the reasons that is causing the rail wear at the end. So the first reason here is to because of the loose fish plate and fish pole. So we will use the fish plates and two fish poles to connect between the two different rail sections. So whenever these loose fish plates and fish poles are not properly tightened, that may leads to the cause of the heavy impact on these rail ends, and also due to the heavy loads and the large openings. So if this gap what you have provided is more, so that also causes the greater impact. And also if these two rail sections are at the different levels, so that may give rise to the rail at the wear ends. And also the bad condition of the vehicle springs and the poor maintenance of the track, so can cause the wear on the rail end section. Ultimately, whenever there is a rail get battered here at the end portion, so that will result in the poor riding surface of. The other position where you can expect the rail wear, which is a very prominent especially on the curve, is the rail on the sides of the rail head. This type of the wear is more destructive in nature when you compare to the first two types. So now we'll look into what are the various reasons that is causing the rail wear to occur on the sides. So first reason at the curve, so there will be a greater thrust on the inner rail when the train moves at the higher speed more than the equilibrium speed. So and also due to the rigidity of the wheel bases, so there can be a slipping and skidding of the wheels at the curves. So the main reason is because of the effect of centrifugal force. So whenever the super elevation is not provided properly, that's may lead to the that will leads to the higher concentration of stresses on one rail with respect to the other. That will causes the rail on. So now whenever rail wears occurs, we have a allowable limits for the wear. So in India, the prescribed limit is 5% of the total weight of the rail section. What is this weight of 5% wear? So now in India, we can either use 45 kg per meter or 52 kg per meter rail weight or the 60 kg per meter of rail wear. So now when after the metal has been worn out, so now when you weigh the metal, so it should not be more, loss of weight should not be more than the 5% of the total weight. So how do you get 60 into 100? So 60 into 5 divided by 100. So that will be equivalent to 3 kg. Okay, so after the rail has been worn out, when you weigh it, so there should be, if the rail section has, the weight of the rail section has reduced more than 3 kg, so such rail section has to be replaced with the new rail section, or that wear has to be rectified. So now we'll discuss what are the various methods to reduce the rail wear. So we know that the limits of the rail wear should not be more than the 5% of the total weight of the rail section. So whenever you find the rail exceeds the prescribed limits, that rail must be replaced. So now some of the methods with which you can minimize the rail wear is with the use of the special alloy steel. So that can reduce the rail wear, making the steel what you have used, the stronger steel, so that will reduce the wear. And also the regular tightening of the fish plates and the fish bolts and the packing of the ballast is necessary to reduce the rail wear at the ends. So the main reason why the wear is occurring at the end is because of the loose fish plates and the fish bolts. So frequent maintenance is required with respect to that. And also reduction in the number of joints, so by providing the welding. And also when you provide the welding, so what that can minimize the reduction and reducing the wear at the ends of the chances of battering of the rail ends can be reduced by reducing the number of joints by welding. So and also there should be a reduction in the width of the gap and use of long bedded rail, etc. That will reduce the wear. Okay, especially so this is with respect to the the way that will occur at the end of the rail section. And also the welding and dehogging of the battered end in time will also reduces the wear. And we need to have properly maintain the track, and with respect to the special attention has to be given to the joints, and the gauges has to be maintained properly, and correct adhesing of the sleepers or use of the bearing plates need to be provided to reduce the action of the wear. And the lubricating oil is used on the gauge face on the outer rail on the curve, so where the chances of occurrence of the wear is more. And also the curves interchange the inner and outer rails frequently, so that there is a change of phase at the curves. And the last option is the application of the heavy mineral oil in case, especially in the case of corrosion of the rail is expected under the adverse action of the atmospheric condition. So apply the heavy mineral rail, so we can reduce the rail. So with this method we can reduce the rail wear to some extent, but you cannot completely eliminate the rail wear. So each and every rail section which is subjected to the moving load, so it will obviously wear can be expected. Okay, so we cannot completely avoid the rail wear, but with the help of this method we can reduce the chances of replacement of the rail section, and we can ensure that the whatever the wear occurs, so that will be within the prescribed limits. So now let us look into what are the various types of defects that can occur in the rail section. So these defects are categorized into the first one, the corrugated or roading of rails. Second is hog rails, kinks in rails, and the buckling of rails. So we'll be discussing about each and every defects in details and what are the remedial measures to overcome those defects will be discussed further. So the first type of defects what you can see in the rail sections are corrugated or roaring rails. So in certain places like where the frequently brakes are applied or at the places where the train starts, so the head of the rails get found to be corrugated compared to the other section of the track or the straight section. So that will be very smooth. So as you can see here, so here the corrugations will be formed on the head of the rail section. So because of these corrugations that are there in the rail section, that will create the whenever the train passes over such rails which has been corrugated, a roaring sound will occur. So that roaring sound will be very unpleasant to hear, and that's why this kind of defect can also be called as the roaring rails, corrugated rails or the roaring rails. So now here what is the reasons for occurrence of such type of defects? So here the conditions can be called as the peculiar in its nature of occurrence. So it is peculiar in the nature where it has been occurring, and also it has been peculiar reason for the occurrence of the corrugation. So now let us look into the what are all these peculiarities. So some of the peculiarities which includes in the nature of occurrence, so that includes, so the corrugation can occur on any part of the rail section, and if any one part of the rail section is get corrugated, the entire rail section gets corrugated. And also this can occur, the corrugation can occur at any gradient and on any track, so there is no restrictions over it. And when the new rails are laid where the corrugations are prevalent, the new rails also found to get corrugated. And the next one is the where the corrugation will occur, which part of the rail section which will be subjected to the corrugation. So now we also call that the corrugation occurrence of corrugation is also peculiar in nature, and it is found that the corrugations are occur in the places where broken bricks are used as the ballast. So usually we will use the stone aggregate as the ballast. We can also use the clinkers, broken bricks, and also the locally available muram soil as a ballast material. So these corrugations are found to occur wherever the ballast consists of the broken bricks, and also at the places where brakes are applied to stop the train or in the places where the train start, and it can also occur in the electrified section of the railway track along the tracks passing through the long tunnel. So these are some of the places where the corrugations can occur. Now what are the causes that will cause the corrugation? So now and next, what is the cause that is making corrugation? So there is no definite cause why the corrugations will occur. So some explains that the corrugations are due to the phosphorus in the composition of the rail steel, and some others give the reason that the resiliency of the track has an important bearing on the occurrence of the corrugations. And some attributes to the reason that intensity of weight that is being transferred over the small area of rails, so which will not be uniform, and that may forms the corrugation. So there is no particular cause. We don't know what is exactly the one which is causing the corrugations, but each and every researchers has found explain the corrugation, the cause of the corrugation in the different manner. So now what is the remedial measure to overcome these corrugations? As we can see, the corrugations occurs on the head portion of the rail section. So those corrugations are removed by grinding few centimeters of the rail head. Okay, so that grinding can be done with the help of the special grinding train, so which is having a capability of to move at the speed of 3 kilometers per hour. So when the grinding is in action, so with the help of this, you can remove those part which has been corrugated. And the next defects we have is the hog rail. So this hogging of the rails can be seen at the joints. So whenever there is a battering of action of the wheels over the end of the rails, what will happen? These ends get battered. It get bends down and it will reflected at the ends. So these such rails we call it as the hogged rails. So this hogging occurs because of the loose packing under the joints and also because of the loose fish plates on the fish boards. So this defects will cause the rough riding surface to the railway sections. So now what are the remedial measures to rectify these hogged rails? Some of the methods include cropping of the rail section, replacing, welding and the rehogging. So in the cropping, what we will do is whichever the part which has been hogged, so that part will be cut off and the fresh holes are made to fixing the fish floats are provided. Next one is the replacing. So we will replace whatever the rail section which has been hogged, replace the rail section with the new rails. However, the replacing this section is highly uneconomical. And the third option what we have is the welding. Hogged rails are brought to the level, so wherever the portion which has been batted, so that will brought to the level by welding over the worn out or the bent portion at the ends. And the last method is the dehogging. So this method of straightening the ends by means of equipments called Jim Crow or dehogging machines. With the help of these methods, we can actually rectify the hogged rails. So the next defect is the kinks in rail. So as you can see here, one part of the rail section is moved apart. So when the ends of the adjoining rails smoothly slide out of the position, that defect we call it as the kinks in rail or shoulders in rail. So now what are the causes for occurrence of kinks in rail? So this can occur because of the loose packing at the joints. It can also be because of the defects in the gauge and alignment and the defects in the cross level at the joints and uneven wear of the rail head. So now what will happen if the kinks in rail occurs? So this will cause a unpleasant jerk in vehicle passing over them. And due to the uneven wear of the rail head, so these kinks can appear at any places other than joints and it will affect the smooth running of trains. And the third effect is the series of kinks are seen at the curves due to which defects in gauge can occur, alignment can be disturbed and the cambers can also be defected here. So with this effect, the turning operation of the train will be difficult for you. So what are the remedial measures to overcome these kinks? So by correcting the alignment at the joints and curve location, you should have frequently maintain your tracks to check for the correct gauge, alignment and the camber at the curve location. And also the proper packing has to be done at the joint portion and the periodic maintenance need to be done with respect to the cross levels, gauge, alignment and welding of worn out portion etc. need to be done to minimize this effect of the kinks. Then the last defect what we can see is the buckling of rails. So as you can see here, the part of the portion of the rail section is moved out of the position. Okay, so this bending of the rails we call it as the buckling of rails. So what is the reason for occurrence of this buckling? So this is mainly because of if you have provided insufficient gap for the expansion of the rail section. So that will give rise to the buckling of the joint. So now what are the other reasons? So the first reason as I told you, when the expansion gap is not sufficient, so that the rail section will not have enough place to move because of the thermal variation, that will lead to the buckling. And also the fish plates and fish bowls are very tight. So when you have provided very tight fish plates and fish bowl, your rail sections will be restricted to the movement. So that may lead to the buckling. And also due to the presence of longer welded rails on a weak track. So when you make your rail section long by providing the weld, there will not be have a sufficient gap for the expansion. So that may lead to the buckling of the rail section. And buckling of these rail section cause many times the serious derailment have been occurred. So it's a very serious defect and wherever you see the buckling of the tracks, that need to be rectified immediately. And what are the remedial measures? So I have understood what is the cause which is making the buckling. So now to remedial measures has to be taken one with respect to those causes. So the first remedial measure is the blast section, sleeper density and rail section must be checked frequently and need to be designed and redesigned if it is required under the various safety under the various stresses. And also the number of welded joints should not be very long, and also the provision of sleepers and the anchors of welded rail should be done. So what are all these steel sleepers and the anchoring of welded rails? So will be studied in further when we discuss upon the railway fast turnings. And also the proper lubrication of the contact surfaces of the fish plates and the rails should be done. So whenever you provide a proper lubrication on the fish plates, so your rail section will be easy to move under the thermal expansion, and the sufficient expansion gap should be provided by taking into the account of expansion of rails due to rising temperature in that particular rail region. And the last remedial measure is that fish plates should not be tightened so hard to prevent the expansion or the contraction of the rails. So with these remedial measures, we can overcome the dehogging in the rail section. So these are only some of the defects that can occur in the rail section. With this, I'll conclude this session, and in the next session, I'll be discussing upon the various failures in the rail section and also the joints that are provided to connect the two different rail section. Thank you, everyone.